Good afternoon to all. Today we are going to see about the power system analysis. Myself, I'm Shiny Pradeepa, an assistant professor in EEE department. So first we see about what are the power system. Normally the electric power system consists of three stages. First one is generating station, second is transmission station, and third is distribution station. So in generating station we are generate the electrical power with the help of renewable and non-renewable energy resources. So after we generate the power, we given to the transmission side. In transmission side, we transmitting the electrical power, and finally, we third stage is distribution system, and then in distribution system, we distribute the power to the consumers. So let's see about the what are the functions of the power system. So first point is we have to monitor the voltage at various buses. So what are the quantities involved in these buses are, first one is real power and second is reactive power, and third one is voltage and phase angle. So these are the quantities we have to monitor the power system network in various buses. And second is we have to design the circuit breakers in the given power system network. And the third function is we have to plan for the future extension of the power system network. And fourth is to analyze the power system under different fault conditions. So in power system there are three fault conditions in the system. So one is single line to ground fault, and second is line to line fault, and third is double line to ground fault. So based on the fault category we have to analyze the systems. Next, fifth function of the power system network is to study the ability of the system for small and large disturbances. We can mention this small and large disturbances by stability studies. So these are the five functions involved in this power system. Next, we see about what are the structure of the power system and what are the process involved in the power system network. So, what are the components involved in this power system is there are six components involved in this power system network. First one is generator, and second is transformer, third is transmission line, and fourth is substation transformer, and fifth is distribution transformer, and sixth is transmission loads. So these are the components we are used in the structure of electric power system to generate, transmit, and distribute the electric power to the consumers. So these are the general structure, electrical structure of the power system network. So here we can see there are three stages. First is generating station, and second is transmission station, and third is distribution station. So in generating station, we are using with the help of generator, we are generating the electrical power. So what is the generator principle? Generator principle is we have to convert any form of energy into electrical energy. So the normal generated electrical level is 6.6, 10.5, 11, 13.8 and 15.75. These are the normal standard electric voltage level in the power system network. So with the help of generator, we are generating the power. So first stage is completed. The second stage is transmission stage. In transmission stage, there is two stages. So primary and secondary transmission. And third stage is distribution. In distribution also, there are two categories. One is primary distribution and secondary distribution. And finally, we distribute the power to the consumers. So next we see about the transmission and distribution side in the next slide. So this is a transmission slide. So in transmission system, it supplies bulk power to the consumers. So in transmission side, the normal tolerance of line voltage level is whether it's plus or minus 5 to 10% due to the variation of the load. So these are the normal tolerance level in the power system network, that is 5.5 or 10%. So before we in the structure we can see that is the two stages, that is primary and transmission side. So let's see what are the primary transmission process involved and what are the secondary transmission process involved in the power system network. So this is the power system in primary transmission. So in primary transmission alone, we are using the step-up transformer. So why we are using the step-up transformer is, if the generated power is transmitted through the transmission line, means without stepping up, means then the line current and the transmission power loss would be high. So to reduce the line losses and the line current, we are using the step-up transformer. So in the primary transmission alone, we are using the step-up transformer. Remaining three stages, that is a secondary transmission and primary distribution and secondary distribution, we are using only the step-down transformer. So only the primary transmission alone, we are using the step-up transformer. So what is the purpose of the step-up transformer? Means with the less current and reduce the power loss, we are using the step-up transformer. So the generator voltage is stepped up by using the step-up transformer in the primary transmission. So the normal primary transmission voltages are 11 kV and 132 kV and 220 kV. So next second stage is secondary transmission. So after primary transmission is over, the power is transmitted through the secondary transmission. So at the receiving end substation, the voltage is stepped down. I previously explained that is only the primary transmission alone we are using the step-up transformer. So remaining three stages we are using the step-down transformer. So with the help of step-down transformer, we are reduce the power level with the value of 66 or 33 kV with the step-down transformer. So here the secondary transmission, it is the link between the receiving substation and the distribution side primary distribution. So in secondary transmission, here we are using the three-phase three-wire system, and the conductor used in this secondary transmission power system is we call it as a feeders. So these are the two stages involved in this transmission. So that is two stages, one is primary and secondary transmission. In primary transmission alone we are using the step up transformer, and secondary transmission we are using the step down transformer. So the second stage is completed. So next third stage is distribution. So this is the distribution. So in distribution side, the component of all the electrical power system is connected to the consumer side. So here we are distribute bulk power to the industries or any commercial purposes. So in distribution side, the main purpose is distribute the power to the domestic side or commercial side or any industries, or any we have to distribute the power to the small consumers. So here also, this distribution side, there is a two category. One is primary distribution and second is secondary distribution. Let me see about what are the process involved in this primary and the secondary distribution. So first is the primary distribution. So at the primary distribution side, here we are using the same procedure, that is step down transformer. With the step down transformer, we are step down the voltage to the value of 11 kV or 6.6. Here there is some bulk amount of power is given to the consumers. So it is a link, and this the primary distributor is it forms a link between the secondary substation and the distribution substation. Here we are using the three-phase three-wire system. So some bulk amount of power is distributed to the consumers in the primary distribution side. So the final stage is secondary distribution. So let me see about what are the secondary distribution process. So finally secondary distribution. So at this distribution, so we are using the step down transformer. So that is finally the step down voltages. One is a 400 volt for three phase supply and 230 volt for single phase supply. Based on the commercial purpose, we are using the distributed power. So here also we are using the step down transformer. So these are the normal structure of electric power system. That is there is three stages. First is generation, and second is transmission, and third is distribution. Generation, we are generating the power with the help of generators. Generator converts any form of energy into electrical energy. So any form of energy means it may be either renewable or non-renewable energy resources. Renewable and non-renewable means coal, wind, solar, thermal. So these are the examples of renewable and non-renewable energy resources. So with the help of these resources, we can convert this any form of energy into electrical energy with the help of generator. So second stage is transmission. In transmission, there is two stages. One is primary transmission and second is secondary transmission. So in primary transmission, we are using the step up transformer. So what is the purpose of step up transformer means I already explained. That is if we step up the voltage without the step up transformer means then the power loss and the line current will be high. So to reduce the losses, transmission line losses and the line current, we are using the step up transformers. So in the remaining three stages, that is a primary secondary transmission, primary distribution and secondary distribution, we are using the step down transformer, and finally we distribute the power to the domestic side, commercial side or any industrial purpose. So finally we distribute the power for 400 volt for three phase supply consumers and 230 volt for single phase supply consumers. So what is the need for this power system in planning and operation means? So Normally, the operation planning covers the whole period. It can be ranging from the incremental stage of the system development. So, the system operation involves the area of the network and the space and the regional and the national load dispatch. Normally, the power balance equation is given by the PD is equal to summation and 1 with I is equal to 1, 1 to n. N be the total number of the system with PGI. PG means power generation and PD means power demand. So if this equation solves the convergence means we call it as we call it as that the power system network gives the good economy and the security. So here the structure in the below figure we can see what are the planning process involved in the power system network. So first stage is planning and second is implementation and third we have to monitor and we have to compare the results with the previous methods, that is already existing methods, and finally if there is any fault or any failure occurs in the power system means we have to take the corrective action. So these are the general procedure involved in this power system planning and operation. So what are the steps we have to follow for the planning and operation of power system is, first we have to plan the power system network for future extension or any other purposes. Second, we have to implement the plan and according to the procedure. Next, third is we have to monitor the power system network categories. Next, fourth is we have to compare the results with the compare the voltage results with the previous methods. That is, there is many conventional methods available. We have to compare the results voltage results with the conventional methods. Next, fourth point is if there is a any undesirable deviation occurs means then we have to directly go for the planning this power system network. If there is no deviation means then take the corrective action. That is, if there is any increase or decrease, then go for the corrective action process. Next is what is the finally we have to analyze the power system. So after planning and operation of power system, we go for the analysis of the power system. Normally the standard power system analysis is three categories. One is load flow analysis, and second is short circuit analysis, and third is transient analysis. So let's we can see about what are the process involved in these three methods. So first is load flow methods. So in load flow analysis, there are four quantities we have to calculate in this load flow method. First one is voltage magnitude, second is current, third is real power, and fourth is reactive power. So these load flow analysis means there are three load flow methods available in this power system network. So first one is Gauss-Seidel method, second is neutral traction, and third is fast decoupled load flow method. So these are the conventional methods, standard conventional method involved in this load flow analysis. These conventional methods depends on the iterative processes. So if the number of the iteration depends on the convergence criteria. If the system is large means then it takes more number of iteration to converge the load flow solution. So these are the process involved in this load flow analysis. Next, second is short circuit analysis. Short circuit analysis means we have to calculate the voltage magnitude and the current flowing through the power system at various time intervals during the fault conditions. So I already explained that is there are three types of fault involved in this power system network. One is single line to ground fault, second is line to line fault, third is double line to ground fault. So based on the fault, we have to calculate the magnitude of the current flowing through the power system. Next, second is second thing we have to calculate is it can vary from time to time until the steady state condition is reached. Because based on the fault only, we have to analyze the quantities that is measured in the power system network. So these are the things we have to involve in this power system. So I summarized what are the things I have explained in the previous section. So normally the power system consists of three stages. First is generation, transmission, and distribution. So in generation we are using the generator, and transmission and distribution there are four stages. So finally we distribute the power to the consumers, and after the generating the power, what is the need for the power system analysis and for planning and operation. In planning and operation, what are the we have to plan and monitor and compare the results with the existing methods. If there is any undesirable action occurs, means we have to we have to take care of the corrective actions. Next, third is what load flow analysis. In load flow analysis in the power system, there is there are three analysis in the power system. One is load flow, short circuit, and transient. So these are the process involved in this power system network. Thank you.